we are learning about this one. Factors affecting the rate of dissolution. Factors affecting the rate of dissolution. Means the amount of solute dissolved in a solvent in a given time interval is called rate of dissolution. The amount of solute dissolved in a solution or in a solvent in a given time or per unit is called rate of dissolution. This rate of dissolution depends on three factors. One, stirring. Two, temperature. Three, size of particles. These are the points. So now let us say stirring. Take two glass beakers. In one beaker, you take the some 2 gram sugar. The second beaker also take the 2 gram sugar and add 100 ml water. 100 ml water. Here also 100 ml water. Now this beaker kept aside as it is. This beaker, you take a spoon and stir the solution components. These two components stir it. So while we are stirring, what happens while we are stirring? The solvent present that is touching with the solute changes quickly so that the solute quickly dissolves. It takes less time. But here the solvent not quickly changing around the solute, it takes more time to dissolve. So here the rate of dissolution is less. Here the rate of dissolution is more. So the rate of dissolution depends upon the stirring. As we stirring the two components, so that the solvent encircling the solute changes quickly, so the solvent takes away the solute quickly. So therefore the rate of dissolution is more. But in this case the rate of dissolution is less because the solvent molecules encircling the solute particles diffuses slowly. That takes more time. Therefore the rate of dissolution is less, here the rate of dissolution is more. Now take the temperature. Again you take the two beakers. One beaker contains 10 gram salt. Another beaker also contains 10 gram salt. Now add 100 ml water. Here also here is a 100 ml water. Same in the process. Now in this case, keep this beaker aside without changing the temperature. But here provide the temperature by heating. Provide the temperature by heating. Just to take the burner and provide the temperature. As the temperature increases, what happens here? The rate of dissolution increases, because as temperature increases, the space between the solvent molecules increases. So easily the solute molecules kinetic energy also increases. They are quickly moving through the solvent, so the rate of dissolution increases. Here the rate of dissolution is more as the temperature increases, but in this person where the temperature remains constant, there the rate of dissolution is less. So in this case, rate of dissolution depends on temperature. As the temperature increases, the rate of dissolution increases because the space between the solvent molecules increases on increasing temperature. When you provide temperature means heat energy. When you provide, what happens? Temperature increases. What happens? The space between the molecules increases by increasing the kinetic energy. At the same time, the solute particles kinetic energy also increasing, so they are easily breaking one another. So they are moving through the space between the solvent molecules quickly. Therefore, the rate of dissolution is high. That is the second. Third, size of particles. Now take two beakers. In one beaker, 10 gram salt. Here also it is a 10 gram salt. But here 100 ml water, here also 100 ml water. Both are the same. Water is same. Now here what happens here? Here the salt, large size particles. We are calling gandu particles, large size crystals. Large crystals. Here is a small crystals, fine powder. Small crystal is fine powder. So when you add these two, here you find the crystals are large in size. Here the crystals are very fine powder. When you observe these two, here the time takes less for dissolution. Here the time takes more for dissolution because of the large crystals. So this indicates size of crystals also is a size of crystals decreases, the rate of dissolution increases. Means fine powder dissolves quickly, takes less time, and the large crystals that takes more time, the rate of dissolution is less. Here the rate of dissolution is more. So therefore, the factors affecting to the rate of dissolution is 3: stirring, temperature, and size of particles. How they are affecting? See, stirring. As the stirring increases, the rate of dissolution increases. So the rate of dissolution increases on stirring the solution. Second one, the rate of dissolution increases on increasing the temperature. Rate of dissolution increases on increasing the temperature. Third, the rate of dissolution increases on decreasing the size of particles. Rate of dissolution increases on decreasing the size of particles. So smaller size particles dissolve more easily than large size particles. That is the answer you can write. Okay. Next one is the solubility. Next topic is the solubility. Solubility means the amount of solute dissolved in the given solvent, given amount of solvent. The amount of solute dissolved in the given amount of solvent at a given temperature. At given temperature. This is answer. So the amount of solute dissolved in a given amount, here given amount means 100 gram of solvent at a given temperature is called solubility. Okay, so the solubility also depends upon the size of the particles. Okay, and also depends upon the nature of the substance. Nature of the substance. So solubility is equal to amount of solute by amount of solvent into 100. Amount of solute by amount of solvent into 100, it is called solubility. Solubility is the amount of solute dissolved in, here amount means 100 gram. 100 gram solvent at a given temperature is called solubility. Okay. Now, second point, concentration. Second point is the concentration. So, what is meant by concentration? Concentration means amount of solute present in a given solution. The amount of solute dissolved or present means dissolved in a given solution at a given temperature. At a given temperature is called concentration. So this concentration can be represented in different ways, in different methods. One is called mass percentage. Second one is mass fraction. Third one is volume percentage. Fourth, volume fraction. Next, mole percentage. Mole fraction. Mole fraction. Next one is molarity. Molarity. Normality. Formality. Like this, different methods we are using to express the concentration of the solution. So what is concentration? Amount of solute present in a given solution at a given temperature is called concentration. So that concentration can be represented. So the representation of the concentration is, here what is the representation? Representation of concentration or the mass percentage, mass fraction, volume percentage, volume fraction, mole percentage, mole fraction, molarity, molality, normality, formality. So like this, different methods are there to express this answer. So For that we are going to see the another one by one. How do you represent mass percentage? Mass percentage means the amount of mass of solute present in 100 gram solution. 100 gram solution is called mass percentage. Once again, amount of solute in grams present in 100 gram solution is called mass percentage. Amount of solute in gram present in 100 gram solution. So here both are in a mass value, so temperature is not necessary. Temperature is not, because mass is not changing with the temperature. Mass remains constant at any temperature. So therefore, amount of solute in grams present in 100 gram solution is called mass percentage. So therefore, mass percentage is equal to mass percentage is equal to mass of solute into 100 by mass of solution. Solution means mass of solute plus mass of solvent. So this is the answer. So next one is the mass fraction. Mass fraction means mass of solute by mass of solution is called mass fraction. So next term. So therefore, it is equal to mass fraction into 100. So mass percentage is also equal to mass fraction into 100. Next, volume percentage. Volume percentage. Mass volume, actually the mass volume percentage is called mass of solute by volume of solution into 100. Mass of solute by volume of solution into 100 is called volume per mass volume percentage. Volume percent is also present, that is called volume of solute by volume of solution. That can be represented, both are in liquid state. Solute and solvent both are liquid state. In that case you can say volume percentage. Here is a mass volume percentage, means solution is a liquid state and solute is a solid state. That's why you can say mass of solute by volume of solution 100 is called volume percentage. Same thing, volume fraction. Volume fraction is equal to mass of solute by volume of solution. So this indicates So therefore you can say volume percentage is equal to volume fraction into 100. Volume fraction into 100 is called volume percent. Like this you can calculate the different ways to represent the concentration of the solution. So let us see the one more examples. One of the examples you can do this. Say for here is a for example is given a solution containing 50 gram common salt, 200 gram water. Contain solute 50 gram. Solute means nothing but here is a salt 50 gram. Solvent is nothing but here is a water. So water is a 200 gram. Then what is asking? Calculate the concentration in terms of the mass percentage. Calculate the concentration. Calculate the concentration in mass percentage. Mass percent means solute is mass, solvent is also mass. Both are mass. So you can write the mass percentage. So then as we said here, mass percentage is equal to mass of the solute by mass of the solute plus mass of the solvent. So that is equal to here. What is answer? You can write mass of solute by mass of solution into 100. So according to this equation you can find mass percentage is equal to, what is the mass of solute is here? 50 gram by mass of solute plus mass of solvent together is called solution. So you can write mass of solute is 50 gram plus 200 gram. So is equal to 50 by 250. 50 by 250 means 0.2. So 1 minute into our size. This is a mass fraction only got it. Mass percentage we can get into 100 is equal to 50 into 100 by 250. 0 cancel. 5 ones are 5 5s are 5 ones are 5. So it is equal to 20%. So you can write the answer is here. Mass percentage is 20. This is called mass percentage. So next one is the mass volume percentage. Let us see another one. Mass volume percentage. Solute is, example 2. Solute is 100 gram. Solvent is 200 ml. Next, solute density. Solute density is equal to 1 point, not point, okay, 1.5 gram per cc. This is the density of the solute. Now, you can say volume of the solute. Volume of the solute is how much? Mass into density. Mass into density. So that is equal to 100 into 1.5 is equal to 150 ml. 150 ml. That is the volume of the solute. So volume percentage is equal to mass of solute into 100 by volume of solution. Volume of solution means solute plus solvent. So therefore volume percentage is equal to mass of solute into 100 by volume of solute plus volume of solvent. So it is equal to 100 into 100 by 150 plus 200. So therefore volume percentage is equal to 200 by 350. So 0 0 cancel, 20. So you can write 0.30. So it is 0.571%. 0.571% is there. So here weight is how much? 100 into 100 by 150 plus 200. So we can calculate the answer is 0.571% volume percentage. So this is the way you have to calculate this answer. Okay. So now we can continue this next class.